इसके बाद okay 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 Nitin, you can start with the recap, then we will formally start the program.
Okay, so good evening, everyone. For those who are in the last class, you might remember we started with a very basic introduction of R, like what is the philosophy of R, what is vector, matrix, data frame, how do you slice, select two, three elements from the vector. We discussed R as a calculator by doing addition, subtraction, and many other arithmetic operations. Uh, we ended up the session by learning how to import data into a data frame by from multiple sources like an Excel file or a SPSS file or even a Stata file by both using codes and by using click to the GUI interface. So today's plan is to continue with the imported dataset. And of course, as you know, when you import a dataset into any software suite for that matter, you require some cleaning of the data, like select only relevant variables, select only relevant rows from the entire dataset, and then maybe do some other commutations like if the variable's logarithm is not there, add a logarithmic transformation to the variable, maybe add a square transformation. So we will learn all that stuff in the first part of the lecture. Then I plan to teach how to do summary statistics, then maybe some cross tabulations using different packages and how the output varies according to different packages. Finally, we'll talk about regression. Simple OLS regression, no econometrics. I'm not going to relax assumptions and make the model very complicated. It will be just regressions. But how can you do it for large number of groups, large number of variables, and yeah. And finally, we'll see how to get the output from R to a very nice report format. Like maybe if you are putting your report in your results into a LaTeX document or even a Word document, how do you do it without copy pasting and then editing the document in editing the table and results in your document, rather editing it in R firsthand, so that your processing in the final stage is very minimal. It has its advantages because once you change the model and then you rerun it, still your output will not require much post editing if you do inside R itself. So I'll show you some examples of that, and yeah, that's the plan for today. Thank you. We'll wait for a couple of minutes more and then we can start formally.
We will start now. I would like to invite Tyasha Mishra to welcome the speaker of the day, and formally we can start. Tyasha Mishra, but you.
Mr. Nitin M is currently a doctoral student in the Department of Humanities and Social Sciences, IIT Kharagpur. He has completed his master's from Pondicherry University and MPhil from University of Hyderabad. He has been using R since 2015. He is a recipient of scholarship offered by University of Minnesota and had attended the 2021 conference for R users. He has also given lecture for using per package at R users Boston Group in 2022.
Shall I? Thank you,
Uh,
Tiyasha, for a nice introduction. Shall I, Zohar?
yes, sir. Yes, sir. You can start now.
Okay, so let me share my screen from last. Okay, so yeah, this is where we stopped last time, and I'll quickly show you how to import the data again because that is where we start today. I'll not go to the basics of the class covered last session. So I have a data. So if you see, I have a data in the folder data inside my project window, which I have discussed in the last class. I had to import this data, this table, table. Okay, how do I do it? You need to use a package called read Excel first. If this is not installed in your system, you need to use install.packages. and read Excel. This might be installed already, but if not, you can install this, and then you have to load the packages. Like I already said, R is not like your normal other statistical suites like Stata or SPSS, which by default comes with all the capabilities inbuilt into the suite. R has packages which extensive capabilities. So you need to load the packages every session that you are using. You don't need to use this command every session. Once it is installed, it will be there in your system always. But this, you have to library command, which is used to load up the packages. You need to use every time you are using an R session for the first time. Okay, right. So I load up the data into an object. I told you everything you had to store inside the memory. So let me clear up the memory first. So if you are just using this command without assigning it to an object, okay, by the way, this is the path of the file. Okay, I also discussed why you should not use an absolute path like this. Rather, I'll prefer to use a path like this, where here package will give you the direct path of the data. Okay, I'm not complicating it again. So when you use just this command, read Excel, unlike in Stata or SPSS, when you just give the file name, it won't. Sorry, I have not the command. Now, if you use this command without assigning it to an object, it will read the data and it will come only in the console here, but it will not be there in the environment. You can see the environment is empty. Okay, when the environment is empty, you cannot use this data for any of your operations or whatever. So you have to always assign it to an object. I prefer to always use df if it is a data frame. So I import this data into an object called df, and now you can see df will appear in the global environment. So DF is a data frame, as I have discussed in the last class. That is one type of container in R where you can store all rectangular data. Okay, other type of object where you can store rectangular data is matrix, but matrix has its limitations. I told you last time. In data frame, unlike matrix, you can each column can have its own type. In matrix, every column will have same type. That's the difference. So if one column of your matrix is character type, all the columns should be of character type. But in data frame, you can have a second column as character, third column as numeric, fourth column as date, or any other combinations of that. Okay, so now when you check is dot data dot frame df, you can see that it is true. So DF is a data frame. Data frame is a very important, container type in R for storing rectangular observations. So you have to make sure that your data is imported in a data frame format. Now you can see that this is not in a format that we want it to be. Sorry, yeah, you can see that there are a lot of NA values. The column names are not specified, and many other issues. Even the date, this, and obviously 1991, 92. This is a date available in Indian format. This is not. This date cannot be understood by any software suite for that matter. You have to do a lot of pre-processing in this data to get it useful for an analysis. Okay, I'll not show you the entire stuffs there, but let me do some wrangling. You can always research some wrangling. How do you do that? The first step itself is even easier. You could have done given some more arguments here. Rather, I will use this command df2. Now you can see skip equal to, rather given skip is equal to 3. Just a minute. I see that someone has a doubt.
Nitin,
Yeah,
I
yeah,
was just asking you to,
yeah.
if possible, can you share this data in the chat box so that others, if they are doing, they can
Yeah.
do it along with you.
Okay. Okay. Just a minute.
Yeah.
Uh, I will how to attach the data? No, it's there is no way to attach this, right? There is no way to attach this actually. That okay. What you can do is this is the data set downloaded from DBIE database on Indian economy. Can I send you? How do I share this? Can I put it in WhatsApp maybe?
Hello?
Yeah.
Hello? Can you
Yes,
share
Shiva.
the link if possible? Like the place where you shared the data from, can you share that link?
Yeah, yeah. From this you can use the source 70 financial markets. Good. Uh, Financial markets. Weighted average quarterly rate. Okay, this is just to import the data. We'll work with a real-time dataset which is available to everyone. Okay, this is just to show the imported dataset last time. I'll rather do a different stuff. Please install package. We'll do all the cleaning with another dataset. Use this command install.packages, Palmer penguins. Okay. Or you can go to packages and see Palmer penguins. Okay, this is already installed into my system. That is why I'm not using it. Please install Palmer Penguins dataset and use library penguins. Palmer Penguins. Everyone with me? Please tell me once this is done because we'll proceed with this. Those who are trying to do it along with me, can you please tell me when you are done with this? Okay, I assume you will do this and then you can see a dataset called penguins. We'll work on this. So this is also a data frame. You can see is dot data dot frame penguins. It's true. Okay. So we'll work with the data frame and then see how to do whatever is working on this data frame should be working on any imported data set that you work with, choose to work with, because I forgot to share this data set earlier. I'm trying to work with the data set that is inbuilt into R. Okay. Everyone with me?
Yeah, yes, yes, you can continue.
Okay. Okay, so now we have penguins dataset. You can see that there are two factor columns, and yeah, there is a year column. Sorry, three factor columns. Factor variables, which you might be knowing from the statistics, it's nominal variables. Okay, then you have numeric columns, which is ratio scale. You have also integer variables and anything. So you can do some statistics based on that. But before that, let's see if you want to select only say first three you know first three columns. How do you do that? You pass penguins. Okay, I'll show you multiple ways to select columns. First way is this penguins. Okay, put a comma because this is a data frame. I told you this is a data frame. This is base R approach. Okay, I'll teach you many approaches. Base R approach. And write the command. So penguins is a data frame. So a data frame, when you need to select specific columns, you need to empty the rows because you need all the rows. So if you need all rows but only specific columns, you can put a comma, then select 2 comma 3. This will select only second and third column of this data frame with all the rows. Okay, got it? Because you put an empty space before column, it will choose all the rows. But what if you want only 10 rows? So you can use this 1 to 10, 2 to 3 will select first 10 rows of columns 2 to 3. Okay, is that okay? This is base R approach to select columns. Okay, this is not very efficient, but beginners can start from this to understand the philosophy of R. As I said, you might find efficient solution like tidyverse approach, which I'm going to show you now, which is far more easy to understand and more appealing. But then you will not learn the philosophy of this language. This language works like this. You need to understand. You need to pass rows and columns because this is a data frame. Now, if I need to select the same 2, 3 columns, what will I do using tidyverse approach? Penguins. Then press Control Shift M inside your R Studio. Okay. Press Control Shift M. Control plus Shift plus M. Press Control plus Shift plus M, you will get a operator like this, or maybe something like this, depending upon the version you are using, or some both are fine. This is called pipe operator in tidyverse. Okay, then select. This will give you the same output as this one, but this is called tidyverse approach. So this makes it more in an pure language specific way, right? Your pass, what is this doing in plain English? Pass data pipe into select function to choose columns. This is tidyverse. This okay. Any doubts here to select columns? Okay, so this is also the building block of what is called structured query language or SQL. You always query something. You are querying to choose columns 2 and 3. Tidyverse has many built-in functions to make this job whole easier. Suppose you want to select only columns that contain length. So you need to you do not need to check okay which columns contain length, say third column and fifth column. You don't need to count and all. You can just use select contains. So now you can see that it's automatically selected the columns which contain only length. You can use a variety of functions here. There are many helper. This is called a helper function. There are match function, starts with, ends with, and whole suite of functions you can explore deeper. Okay, this is selecting. What if you need to set you need to impose some conditions? You need to filter for species Adelaide. Okay, what do you do? Penguins filter species equal to Some of you might remember from the last class, you always need to put things in double quote if you are passing a string, and you need to put double equals to check for a condition. If you are using just one equal to, it is called an assignment operator, and this is an conditional operator. So if you are checking, you always need to put double equals to. Don't forget this, else it will throw an error. Now you are, what's happening? This is again another error because when you load some other packages, okay, uh, that package might also contain a function called filter, and that gets masked. So you have, when you are sure that you are using a particular function from a particular package, try to use it like this, else it will throw an error. Maybe I have used some other package here, which is masking the filter function from. Yeah. Is it okay till now? So I think you can do how you can check how to filter for some variables, like what if you want to select data from all the penguins which are living only in the island Torgensen. How will you do that? Uh, you can just change this here. Okay. So you can see this is the way to filter the data. So these are the major operations that you might require when you are cleaning your data. You need to select columns, you need to filter. Then yeah, there is an NA column. How do you do that? Penguins drop underscore NA. This is from package called tidyr. So that package is not loaded. That is why it is not auto completing. Library tidyr. If you load that package and use drop NA, you can see that all the NA observations are dropped. Now you have only 323 rows. Earlier you had, when you click only penguins, you see you have 334 rows. So all the 11 rows where there was NA in at least one of the columns were dropped. Okay. What else do you need to do when you clean the data? Maybe, like I said, you need to calculate the log. You need to transform this variable, say renaming, all other stuff. You can try that. I'll just quickly show one or two examples and then we'll go to summary statistics. Okay. So suppose you need to change the variable name of bill and penguins. Then you need to rename. Again, I have to load the ID. Variables. Rename. I'll just put bill and billion equal to. So now instead of billion, it is just bill. This was the new. So the syntax here is inside rename. You have to pass new name is equal to old name. Okay, that is how you will rename this. Any variable you need to know. There are many other ways you can do. You can rename many columns such as stretch using a pattern, which are bit advanced techniques which I have not discussed now. Suppose you need to take square of bill length now. So how will you do that? Mutate. You will use a function called mutate to add new columns to the existing columns of the data frame. Okay. So suppose I need to add a square of bill length column. So bill square is equal to bill length divided square. So you can see that there is a new column called bill square appeared, which is the square root of this one, 39.1. I think that is correct. And we'll just check 39.1 square. Yeah, it was just rounded it to 1529. It's almost 1528.81. Any doubts here till now? Should I stop? Yes, Sri Lakshmi.
Nathan, what if we need to combine two commands in a single stretch, like select from the first column and second column, like in a command? So
Okay.
if
So
in your
you
data, it's like species of a particular species residing in one island, so
uh,
you
okay,
got it.
sure. Great. That's a good question. So suppose I want to select all the penguins that are residing in, say, island Torgenson, and let's see what are the species available to just get a different feel. Species. So we have three species: leg, Gentoo, and chinstrap, and maybe you have three or four islands if I am island. So you have three different the all the 334 penguins are living in three different islands: Togenson, Disco, and Dream, and are classified into three species: Adelaide, Gentoo, and Chinstrap. So, Sri Lakshmi, if I understood your question correctly, you want to select, say, species Gentoo living in Disco Island. Is that is that right?
Yeah, yeah, yes, yes. Thanks.
Okay. So how do you do that? Penguins. Then you select filter. Okay. You put species equal to say Gentoo. Then if you want you know the difference between and or, right? Now if
Yes,
you
yeah.
want both the conditions, you can put and island equal to, I will put dream for easy typing. Okay, so maybe there are no species like that with so let us check with gen. If you filter only Gentoo, maybe Gentoo is living in only Bisco Island, so that is why. Let us check with that now. And island equal to. So basically, the idea is you can use and or to combine your conditions when you want to filter, right? Is that okay? You can even do many things here, and then you can choose only the penguins that have, say, bill length greater than and bill length millimeter greater than, say, 50. You can do this too. You can pass multiple conditions. Now you see, so you the efficient use of and or is the key here. That is how you combine multiple conditions. Is that okay? Does that answer your question?
Yes, yes, thank you.
Okay, great. So that is basic operations that you do on a data frame. I'm stopping here for passing on to summary statistics. If you have no more questions on this entire cleaning of the data, any other operations that you would like to show me specifically, you can tell me. Else, I'll pass to summary statistics. Anything?
Hello.
Yes, yes, Shivam.
So you use this penguin data right now, right? Like just
Yeah.
which is inbuilt in this R. So
It's not
can you?
inbuilt, it is from Palmer Penguins package. Inbuilt
Yeah.
dataset are empty cars, iris and all. Yeah.
So just like show a bit like how you access these data, like how we get this data into the import this data into the console, something like that.
Okay. So like I said, Penguins data set is not built into the R. It is coming from Palmer Penguins package. So once you use this package called library Palmer Penguins, all the data. This is a pure package only for data sets. Okay, all or you can use if you want to use lot of inbuilt data sets into R, you can use library data sets. So this package has lot of data sets built into R. So when you check data sets, all this data, can you see my screen? So all these data sets are built-in data sets into R, which you can use for variety of operations like see air passengers data. If you use this air passengers data, this is a time series data you can see. You have January 1949, February 1949 value of number air passengers in millions flying into New York. I see. If you can see, you can just see help air passengers. So you can see the description of the data here. It is a time series data, see classic Bobs and Jenkins airline data, monthly totals of international airline passengers from 1949 to 1960. So this datasets package is the package that you can go to for replicating any analysis. But I am very comfortable using Palmer Penguins data, which is the popular stuff among data scientists now to teach R actually. That is why I'm using Penguins data. But you are free to use any datasets of your choice to explore all the operations that I taught you now. Right? Fine.
Yeah, yeah, it's okay. Yeah.
Yeah. So we'll see summary statistics. Uh, First, let's see how to do that. Penguins. Again, I'm doing penguins data. Now, suppose I need the mean of uh, a mean bill length of yeah mean bill penguins. Summarize. So when you use this, okay. So there is a change in package dplyr comment. That's why let's do a difference with penguins. Now suppose you want to do a calculate the mean of bill length of Adelaide species. So how do you do the mean bill length of all the species? So group by species. You are asking R to group by this, then summarize bill length. So now if you see, you can see that here it is first we are asking R to group by penguins into. So now you can see that it is grouping into three species. So it is essentially converting this entire data set into three separate parts. One is species Adley, and then you have species get to and this. And then I'm asking R to summarize. This is not coming. Okay, let's check another packet. I'll come back to that because you can see that this summarize argument is depreciated as per dplyr 1.1, and I have recently updated my dplyr. That's the issue. I will use another package skimmer. Okay, you can install this package. It will also give you all the summary statistics. So let's use that, and I'll come back to this couple of minutes later. So now if you see, you can use skim function from skimmer package and just pass penguins dataset to see all the database. Okay, is the screen visible? Yeah. So you can see that when you use a package skimmer and skim function from skimmer package, it is directly giving you all the data, all the summary statistics that you would want. It is it is separating the data into factor variables and numeric variables, because on factor variables and numeric variables, the summary statistics that you can calculate are different, right? So you can see that what is the total number of count of Adelaide species. Uh, yeah, species you can see Adelaide is 152, Gendu is 124, Chinstrap is 68. And then on island, you can see it is a total 168 penguins live on island with disco, and yeah, like this. And total, you can see that there are 168 male species of penguins and 165 female species of penguins. You can also see the other numeric variables, mean, standard deviation, and all these are quantiles. Okay, and you can also get a histogram plot from schema package. So that is one way to do it. Get summary statistics. You can also try a couple of other packages depending upon what you actually want to achieve. This package is just to get a glimpse. Either you can. This is just to get an idea of the statistics rather than export it into a very good output format. You can also use glimpse function from dplyr to get the same thing. If you use glimpse, again you can see the no, sorry, not glimpse. You can use, so if you use summary, the problem is it won't recognize factor variables and numeric variables. It even took years minimum and maximum sex and all, it gave the correct count because being it a factor variable, but here is a numeric variable. Here is not a numeric variable. It doesn't make sense to get quantiles and all here. You can use another package library, then maybe use GT summary. You can use a package GT summary, which will also give you very good outputs. So when you use this function from, you can see this in my viewer window. You can see the total number of observations, and you know, yeah. So your average length, all these are including NA values. That is why there is a change. You can explore the table summary function. I'm not showing you how to do the cross tabulations in table summary because that is a very complicated package. How to get uh, the mean average length by sex and island by, normally you want by some factor numeric variable by some factor variables, right? For that purpose, I like to use a package called model summary. And inside model summary, there is a function called data summary. So if you use data summary and penguins, data summary skim levels, you can get. I think I like this table more than the table from uh, GT summary. GT summary is normally for getting summary outputs from your uh, tree survey data. So this is the table that I like more, and this is a very good package to get your cross tabulations. It's like say you want to, let's run this code. So now you can see that you are getting mean and standard deviation, mean by sex and by island of two numeric variables, flipper length and body mass. You are getting by sex, you are getting by island, that you are also getting by standard. You are also getting standard deviation of sex and island. So this is kind of uh, uh, typical cross tabs that you may normally want to do. and this is directly, you can directly pass to output. Okay, you see output equal to, if you give latex maybe, so you can get a latex output here, or you can just pass a file name and that will get stored. You can directly insert that into your latex document. So this package will give you a very well formatted output, which you can directly put into your documents. Any questions here in the summary section? I'll stop the summary section here. So these are all package dependent. You can explore your own packages which uh, suits your requirement. There are other packages like Stargazer, maybe table, which gives output according to your taste and preference. Uh, I like model summary package for getting my summary statistics. Any questions?
Uh, can you just repeat once, like the thing that you said about like importing like this thing to the LaTeX file?
Yeah, sure. So basically, data summary has an argument called output. Okay. So when you do this without an output argument, it will always print to your viewer window. You cannot but if you want to export it into a specific document choice, you can use output. Output equal to, if you use latex, it will show you the latex corresponding latex command generated into the console. You can copy paste that into your latex document and get the output. But if you rather want to say, I put output equal to save. 1 minute, I forgot the arguments. Let us see the help of data summary. I'll show you the data summary. If you use the data summary's help, you can see out what are the formats of output that is possible inside this. So you can, yeah, you can use a default dot text dot md dot text. Okay, so if I use new txt, if you pass like this with a proper extension, it will get stored into your current working directory. It will store as a text document now. So you can see that when you do see files and rtalk, so you can see that new.txt has come here. If you open that, or yeah, because I'm sharing only one window. It is, see, if you open that, it will come something like this. But this is not the proper format. This might not be the proper formatting that you might want. You can try dot docx to get a Word document. Okay, now you can see that there is a Word document here. Again, even that might not be very well formatted, because you are directly asking R to pass it, save it as a Word document. Yeah, when I open it and see, I'm seeing that it is not a proper format. How many of you checked this? Did someone check this new.docs? Can someone check and tell me whether you are happy with the output? Hello, hello. Okay, you might try, and you can see that in the viewer window you got a very beautifully formatted table like this. But this is not what you will get when you directly pass this into. Yes, so what you can do is, you can give output is equal to, say, cable extra. Okay, so this, what this does is, the output of this is passed to a different package called cable extra, and with cable extra you can customize your uh, table further. Then this you can pass save cable. Now you can pass a proper, but remember, cable extra can pass only, save only text, PDF documents or text documents. So if you want Word documents, make sure to pass flux table. So flux table will give you something like this. Now even this is not a well formatted table which I would want to. So I like to do everything in LaTeX. So that's a different choice. I'm not going to teach how to do this. You can do this definitely by some modifications here, because this is getting passed as a data frame. You can do some selecting, some rearranging the column names, and do get this done in the format, but that requires some additional task, which I don't have time to spend on. Okay, so that is about summary statistics. You can explore, and if you are not able, you can always drop me a mail. I'll try to help. Okay, let's see regressions. Okay, is it fine? I'll quickly go to regressions and see how much we can cover in the small amount of time. Good. So I'm using couple of packages here again. I'm using for again regression. I'm using an inbuilt dataset from Gapminder package. Tidyverse is for basic data wrangling. Broom is to get your output in a very nice format. Cable Extra and Flux Table to get output in a publication quality table format. Dot Whisker is to make a beautiful plot of that. Okay, right. So let me run couple of these codes. And so now, suppose you are, let us have a preview of the data. So if you see the data, there is data has uh, 6 columns. Uh, for every country, there is every country and every year there are 3 numeric variables: life expectancy, population, and GDP per capita. So I'm trying to fit a regression model here based on population. I'm assuming that population of a country is dependent upon its GDP per capita. Okay, so the idea to pass a regression model in R is to use the function lm. Okay, this is your dependent variable, and separate that with a tilde, and then give your independent variable. Then you have to specify on which data you are doing this operation. This is again unlike Stata and SPSS, because R can store multiple data sets in the memory at the same time. In Stata and SPSS, you don't possibly need to give this argument, because there is only one data in the memory. Okay, if you run this command, you can get an output like this. You can see there is a intercept, and the beta coefficient of GDP per capita, which is minus 275.7. Okay, this is how you do a very basic linear regression in R. Suppose you want to add one more variable, say, which explain a population, you can also add this plus life expense. So once you do this, you can get 2 coefficients and a regression. But you are not able to see the other diagnostics of a linear regression like you normally get in Stata and all. So you can store the result of this linear regression into an object called mode1. Okay, or you could have directly given summary from here. Still, you will get all the errors. So you can see the p-value, the significance, standard error, t-value, p-value, what all you know, what all you want from a linear regression. Yes, who has a doubt? Okay, so you can also see the r square, adjusted r square, f statistic, the overall p-value of the regression, degrees of freedom, and whatnot. Okay, but this is not the way I want you to write a regression model. Always try to write it in a very scalable way, so that you can do some more, like say you want to update the model next time. uh, it is easier. So what you can do is maybe follow an approach like this: dependent variable, ask what is your dependent variable. Say here you can use pop. Okay, then you can determine what are your independent variables. Box is C. Yeah. Suppose I want to do this only with GDP per capita. Okay. Now you can do model to reformulate box. So this will give you a model by default. So the advantage is you can add on to your additional dependent variables you want to add. You can just change here. You are not changing anything in the model here. Model gets updated automatically. Then you can pass lf data equal to. So you can get the same stuff. So here what I'm doing is, okay. So here the independent variable is GDP per capita. So here the model is GDP per capita is a function of uh, population. The problem is uh, actually I was trying to estimate population as a function of uh, GDP per capita. Here you have to give the argument. Let me check reformulate. Okay. First, you had to the problem with reformulate is first you had to pass your independent variables, not your dependent variables. So that is how it creates the model. That is why this got reversed. Actually, you could have done this way in git parts. Finally, give your dependent, which is your dependent variable. This is what you should do. Works. Okay. So you got population as a function of GDP per capita, which was your earlier model. You can take a summary of that. So very basic regressions. Now suppose you want to do this for every country because you see that there are lot of countries. I'm not talking about panel data regression. Suppose you want to fit a model for every country. Okay, how do you do that? Suppose I want to fit it for India. You can do this argument here. This data dollar country will specify subset the data. See, you can see subset is equal to this, and now this is fitted only for uh, country India. I'm fitting a linear regression model population, which is a function of GDP per capita, and we are selecting it only for India. Any questions here till now? You can also get it for, using a for loop. Suppose you want to do this for all the countries, you can use a for loop and do this. Right? So this is the structure. What I'm doing is creating an empty list regression countries, and for I in data dollar country. So this will choose each country one by one. That is this argument. I'm fitting a regression model here. Now, when you run this rig countries, you can see that you'll get it for every country. For Zimbabwe, you're getting, see, you're getting it for Zambia, for everything. But like I already said, this is not a very efficient method because you will have to copy paste this result into your table, paste it, do the post processing yourself, which is not efficient. Okay, so you can use some advanced functions from R called map and grouping. So I have already so basically you are using some advanced technique like this. And then if you do, I will make this codes available. When you run this um, command and nest coefficient 1, now you can see that you have all the stuff available. Let me take that out. Nest coefficient 1. So now you can see that you have a data frame with all the countries, term, estimate, and p-value, which is what I wanted. You can choose what all you want based on this function that I have done here. Now you can also pass this into a very beautiful output. Okay, let's do that now. So this you can now you can see that it gives a table for each country. Other unlike here you had an entire table not split according to country. All these are personal preferences. Okay, how do you want the output to be? So you can what I'm showing is it's just possible to do anything. Now I pass this into a output. Let me get a very basic word output. Okay, once you do this, I'll show you the output of this tables. So you can see that you can see the output of, yeah. So once you do that, you can get for each country you are getting a table like this. So you need not do this maybe, but what I'm saying is, suppose you have a huge data set and you need to do regressions by group, and you need output of each regressions by group. You can do this. This is very easy. Unlike whether you want if you want to do this in Stata, think of you doing this 192 times in Stata and getting an output like this. It is very tedious, right? Of course, Stata has its own way to do this, but even that is tedious. You had to use a for loop. Okay, but even what if I'm not happy with even this output? Even this is not a very publication quality output, right? What will I do? Let me see if I have. Okay, so this I have not saved into a very beautiful output. I will show you another example. Let's take some time series data and show you some example of publication quality tables. Okay. Okay. So suppose so for this you need a package called T series. Yes, Sri. Yes.
Nitin, you are still on the Word page
Okay.
for us.
Oh, sure. Thank you. Okay. So that I showed you a very basic table that you can create from your regression outputs, uh, rather than copying and pasting your results from R console into your document, modifying that every now and then. Every time you change a model, you had to do that, which is not efficient. Okay, let's see how you can do this more efficiently. I'm using a package called T series, and I'm using data US economic data, which is available in T series package. Okay. Now, at least some of you might be familiar with augmented Dickey-Fuller test that you had to, uh, which is a prerequisite for many time series operations. So suppose I want to, let's check the US economic data first. So if you see the US economic data, you can see it's a time series data from 90 all the way from 1954 Q1, and it has four columns: log of M1, log of GNP, then your ex, real real exchange rate, uh, and not sure what is RS. RS is real exchange rate. Okay, let it be. So suppose you want to do an ADF test of log M1. How do you do that? It's very simple. You just need to do adf.test. That is not what I'm here for. Let's check it for all the columns. You see that for all four columns, you can use ADF test by using a for loop, which we already discussed in the last regression. But let's do this using a, so you can see that I have written some custom functions myself to get all the unit root tests done. Most, not unit root, ADF test, PP test, and KPSS, which are three basic tests that you will do for time series. Let's see how you will get that. And in a publication quality table, let us see that. So you can see that I have conducted tests for all the four variables and got the value for all the three tests, their corresponding statistics, used lag length and p-value. This is again in a console, but still not in a proper format. You can use cable function from the cable extra package to get this done. Once I run this command, you can see, let me run up to this. So I hope this is visible to you in my viewer pane. Yes. So you can see that all the four variables are grouped by the test and their corresponding statistics, p-value, and lag length. This table is what you would ideally like to put in your research paper, right? Rather than something like this, which is there in the console, or maybe something like this, which you had to create your own tables. So these kind of advanced operations are not, as of my knowledge, very much possible in Stata. You can get some quality of tables also in Stata, but I'm pretty sure you can't get a table as close to this perfection in Stata anyway. Okay, you can save that in any format you want, in JPG, or because it is cable, you can save only in JPG or PDF. So I will save it as JPG, or suppose you want to do this as a word table, you can pass this into a command function called flex table from like a flex table package. You can do some manipulations to add the desired column names like this. And then if you save this, okay, okay, wait a second. Where is it? Okay. See what is error there. So yeah, you can get an output like this actually from flex table. And if you want to save that column, first column was 3, 3, 3, 4. So maybe I think this should work. Object flex. Now if you see, there is an table 3.docs coming in. Let me show you how it will look in flex table, which is the format that at least some of you might use, Word document. But I will always suggest you to use, you know, LaTeX. Because why? Because it's like this. So even after all the pre-processing, this is the output that I could finally manage from Flux table package. Obviously, because of the um, uh, because of the shortcomings in Flux table package, you can get very beautiful output from cable extra into LaTeX. So that is publication quality output from regressions. So I think I'll stop here for this part again. That's getting too late. Uh, I will make these codes available. Of course, I couldn't explain very detailed because of the uh, one, the time constraint, and two, because some of most I see most of the people here are new faces. Like many people who were there last time are not attending, so even that might contribute to the difficulties. So Jawahar, I'm done for today. Maybe I can come back next time for even.
Yeah, thank you. I hope from your side you have done a great job. Now I would like to uh, call Suam Chogole to propose vote of thanks. Then we'll open for discussion because people, if they leave, then there'll be
Yeah.
issue.
Any doubts? I'll be available
Yeah,
for
exactly. After 2 minutes, we will be open for the discussion.
sure.
Mr. Suam Chogole.
Hello. Am I audible, right?
Yes, 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 Sivam.
Yeah. So yeah, I mean, I have seen several sessions on YouTube maybe, or I have tried to learn it from some of my friends and all. But I don't think I have seen anything thorough and anything as crisply mentioned as like the one that you have told today, and the previous section, previous time also that we have done. So I actually thank you so much for like making this quite informative as you have done. And like it does two things. One is like we are sharing the knowledge, which should be a public good, and as everybody should have a right on this, so everybody should learn. So we are providing a platform for all to learn this thing and take the benefit out of it. So you as a presenter today have done brilliant job in order to like give the people idea about how to use R, and that too with some level of details. You have mentioned so many packages, so many functions in R that can be used quite efficiently to produce the quality stuff. Like I just was not sure about we can like import the outputs from R to the LaTeX files, and we have this kind of stuff so that we can get the outputs in a directly publishable format. So that's a sort of things that you have told. Maybe also the things that you told about filtering the data, and the kind of exhaustive methods that R has to like filter the data and all. So the mention that you have done there, these are quite an extraordinary like I have seen plenty of presentations on YouTube, and several places available. I don't see many people talking these much things. So thank you so much for this. And this is one thing, and like in a way, you are actually setting a sort of stage for the other programs that we are going to do, other lectures that we are going to do. So maybe next week onwards, we will continue with some other techniques with cross sectional data, as we have done last time around. We have just uh, begun with like doing analysis on cross sectional data. So maybe we will go in little details. Maybe we'll do with some DEA SFA techniques. Then we are thinking about going into time series panel data analysis, and we will just go through with both the theoretical stuff as well as their implementations in this statistical tools. So you as a presenter have set a good tone for this thing that we are going looking forward as a platform for all the speakers around. So thank you so much, and I really appreciate, and I just like would like to get the solidarity from all the members that to congratulate you for brilliant work that you have. Thank you so much.
Thank you, Shivam.
And I would like to propose thank you to Mr. Shivam also that he